Hello everyone, welcome to Simplilearn's YouTube channel. Today in this video I will walk you through bagging and boosting, the two main types of ensemble learning. We will first discuss what is ensemble learning with an example. Then we will see what is bagging, the implementation steps of bagging, benefits of bagging, and then we will move on to what is boosting, the steps to perform boosting, its advantages, and finally the differences between the two. Stick around till the last to make the most out of it. In the ever-evolving world of machine learning, where algorithms tirelessly seek patterns hidden with the massive datasets, one technique stands out, that is ensemble learning. Think of it as a team of experts, each bringing unique insights to solve a complex problem. So instead of relying on a single model, ensemble learning blends multiple models, harnessing their collective intelligence to achieve their accuracy and reliability. Much like a conductor harmonizing an orchestra, this method ensures that the different models complement each other, reducing errors and enhancing predictions. Inspired by the wisdom of crowds, ensemble learning demonstrates that collaboration among algorithms leads to smarter, more resilient AI systems, proving that in the quest for knowledge, the whole is indeed greater than the sum of its parts. AI and machine learning jobs are skyrocketing as businesses rely more on the intelligent systems. In India, AI/ML engineers earn an average of 9.5 lakhs per annum. In the US, the average salary is $175,000, with the total compensation reaching to $210,000. The growing demand makes AI/ML one of the most exciting and rewarding career paths today. If you're really interested in building a career in AI, join Simplilearn's ranked #1 AI Masters program by Career Karma and gain expertise in machine learning, deep learning, NLP, and generative AI with the real-world projects and IBM certifications. This 11-month live interactive courses offers exclusive masterclasses, hands-on AI projects, prompt engineering sessions, and career support to help you land the top jobs in companies like Microsoft, Google, Amazon, and Apple. With IBM-backed certificates, industry-relevant AI tools, and job assist support, you will be prepared to thrive in the booming AI industry. Find the course link in the description box below and pin comments. So, let's understand what is ensemble learning. So, ensemble learning is a machine learning technique that combines multiple models called the weak learners or base models to make accurate and reliable predictions. So instead of depending on a single model, it leverages the strengths of multiple models to reduce errors and improve the overall performance. So let's imagine you are deciding where to eat and you ask 5 of your friends for the recommendations. So each friend has a different opinion based on their experiences. So if you take the common choices or one recommended by most people, you are more likely to end up at a great restaurant. So this works better than relying on just one person's opinion. So moving on to the types of ensemble learning. There are two main types of ensemble learning, that is bagging and boosting. They both improve prediction accuracy by combining multiple models. They both aim to reduce errors and make the final prediction more reliable. So the key similarity is that they use multiple weak models, also known as learners, to create a stronger overall model. Now, similarly, in ensemble learning, multiple models make predictions and their outputs are combined either by averaging, that is by bagging, or giving more weight to the stronger models, that is by boosting. So this technique is widely used in the fields like fraud detection, stock market forecasting, and the medical diagnosis, where high accuracy is essential. So now let's elaborate on each topic. First, we will come to what is bagging. So bagging or bootstrap aggregating is an ensemble learning method that improves the accuracy and reliability of predictions. It works by creating multiple random samples from the training data, that is, some data points may repeat. So each sample trains a separate model like a decision tree or a neural network. Finally, the predictions are combined, that is averaged or voted to get a more accurate result. So next come, what are the implementation steps of bagging? Implementing bagging involves several steps, and here's a general overview. The first point is dataset preparation. That is, the clean and processes data, then split it into training and test sets. Now moving on to the second one, that is bootstrap sampling. That is, it creates multiple random samples from the training data, and as usual, some data points may repeat. Now moving on to the third one, we have model training. Train a separate model on each bootstrap sample. Then is prediction generation. Each model makes predictions on the test dataset. Now the fifth comes is combining predictions. So it uses the majority voting, that is a classification, or averaging, that is regression. Then moving on, we have evaluation, and it accesses performance using accuracy, the F1 score, or even the mean squared error. Now the seventh step is hyperparameter tuning. So it optimizes models using the cross validation, so if needed. Now moving on to the last step is deployment. So it basically finally deploys the final model for the real world predictions. Now moving on to the benefits of bagging. So here we go. The first one is it reduces variance. It basically combines the diverse models to stabilize predictions. Now moving on to the second one is it prevents overfitting. It ensures the better generalization on the unseen data. Now moving on to the third one is it handles noisy data, so less sensitive to the outliers. Now moving on to the fourth one is parallel training. Models can train simultaneously, improving efficiency. The last one is easy to implement. It is simple yet powerful for improving the model performance. So bagging is widely used in applications like fraud detection, medical diagnosis, and stock market predictions, making it a key technique in the modern machine learning. Now moving on, we have boosting in machine learning. So what is boosting? So boosting is an ensemble learning method that improves accuracy by training models one after another. So each new model focuses on fixing the mistakes made by the previous ones. So this step-by-step learning helps make better predictions. At the end, all models' predictions are combined using the weighted averaging, that is for numbers, or weighted voting, that is for the categories, to get the best result. So common boosting methods include adder boost, gradient boosting, and XGBoost. So we are moving on to the steps to perform boosting. So boosting models improve accuracy by training multiple models in sequence, each learning from the mistakes of the previous one. So here is how it works. First is start with the equal weights. So the algorithm gives equal importance to all the data points and trains the first base model, that is usually a decision tree. Now moving on to the second one is identify errors. So it basically checks which predictions were wrong and increases the weight of those samples, making them more important for the next model. Now moving on, we have train the next model. So a new model is trained with the updated weights, focusing more on the difficult cases. Now moving on to the fourth one is repeat until optimized. So this process continues until the error rate is low or the set number of iterations is reached. So each model builds on the previous one, making the final prediction more accurate. Now moving on we have advantages of boosting in machine learning. The first one is higher accuracy. So boosting combines multiple weak models to make better predictions, improving the overall accuracy. Second comes less overfitting. So it reduces the risk of overfitting by focusing on difficult data points and balancing errors. Now the third one is it handles the imbalanced data. So boosting gives more importance to misclassified data, making it effective for handling the imbalanced data sets. So we have better interpretability. Since boosting builds models step by step, it helps in understanding how decisions are made. So now moving on to the most interesting part is the difference between boosting and bagging. So the first difference is boosting combines different models to improve predictions, whereas bagging combines multiple versions of the same model for better results. So the goal of boosting is to reduce bias, that is the error due to the incorrect assumptions we have. And under bagging, the goal of bagging is to reduce the variance, that is the error due to the sensitivity to the data changes. So the third point is models in boosting get different importance based on their performance. But in bagging, all models in bagging have equal importance in the final result. So now moving on, we have under boosting, each new model learns from the mistakes of the previous model, improving step by step. And under bagging, all models work independently without relying on each other. So under boosting, we have it works well with the weak models and turns them into strong learners. But in bagging, it works with the best strong models, reducing their variability. So under boosting, the last point we have, it is more prone to overfitting if not tuned properly. But in bagging, it is less prone to overfitting because models run in parallel. Boosting is like a relay race, where each runner learns from the mistakes of the previous one. So while bagging is like a team race where everyone runs separately and the final result is based on all the performances combined. So I think this is a wrap. If you have any doubt, do comment in the comment section below and one of our experts will definitely reach out to you. Like and subscribe to the channel for more updates like this. Keep learning and growing with Simplilearn. Thank you for watching.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.